Welcome to Horn Online Training, Module 61.1. This is the second part of a two-part series on the Supermini HP multi-application system and also the Supermini face clamping. I'm Edwin Tunney, Training and Technical Specialist for Horn USA Incorporated. So the Supermini HP is really a unique tool, a brand new tool to the Horn offering. It's a universal tool for drilling, face turning, boring, and external turning. So the system features a range of minimum diameters and reach lengths up to 2.5 times diameter. So drilling, facing, boring, and external turning all in one tool. Some of the features of the Supermini HP tools are a wiper facet for improved finish. So on the bore side of the tool, you have a wiper facet so you can get more aggressive with your cutting conditions and maintain high surface quality. You have up to 3mm AP on depth of cut from the boring side of things. Obviously, if you drill, you're using the full width of the tool. The tool is made to be on center, so the cutting edge protrudes just slightly past center, so you don't end up with a pip in the bottom of the part. You can drill from solid. I will say, and you'll hear it again before this training's done, this is not meant to replace high performance drills. If you're using any of the Horn DDP or DDM drills, it's not designed to replace those. It's simply designed to give you very aggressive parameters for boring and the capability of doing drilling operations, and then also doing face turning and external turning. So it's designed to save a tool location, save time on your tool changer, and put a lot of different functions into one tool. There are tools offered in 1.5 and 2.5 length to diameter ratios. The grade on this is EG35, which is aluminum titanium nitride, but it high PIMs also with a tin flash coating for wear detection. And then you have two geometries, which we'll talk about. You have the .1 geometry, which is a chip breaker geometry, and then you have a .2, which is a universal geometry. And last, just so I don't forget, the DS of the tool, so the cutting diameter ranges from 3mm to 7mm. So you have a 3mm tool, a 4mm tool, a 5, and a 7. So those diameters to drill from solid. So if we look at the purpose between the two geometries, so you can see the chip breaker geometry is designed, it's a little more closed off on the front. You have an upstand, which gives this a little bit more rigidity and more strength to the cutting edge. It's designed for boring, face turning, external turning. It's not suitable for solid drilling because of that additional material up front. It makes your chip more closed. So it's not recommended to do drilling. To note, one thing, very important thing, is that when you do an external turning operation, you have to reverse your spindle. So if you're running an MO4, you need to switch to an MO3 if you're doing external turning. On the other side of things, on the universal geometry, that is designed for drilling. It's also more universal in materials, so it's designed for steels or P group, ISO group P, stainless steel, iron, and non-ferrous alloys. So P, M, K, and N in the ISO material classifications. Solid drilling, boring, face turning, and external turning. So that's the .2 or the universal geometry. If we look at cutting conditions, you can see why this tool is very interesting, especially if you're doing even just simple boring operations. You can get very aggressive with depth of cut, depending on the diameter. So with a 3 millimeter DS, you can go 1 millimeter deep, and then all the way down to the 7 millimeter DS or cutting diameter, you can go all the way to 3 millimeter. So that's going to cut a lot of time, especially when you're trying to bore out a component. The interesting thing to do is, partner this up with a high performance drill, like a DDM or a DDP drill from Horn, and drill it out. This tool is going to bore out your component and also make the bottom flat. So it's 90 degrees across the front here. So you can make countersinks or any kind of feature and do it very quickly with sort of aggressive depth of cut parameters. Cutting speed wise, you're going to follow the parameters given for the EG35 grade on the Supermini, and those are fairly typical. M material group stainless steel, it's recommended to use the minimum value for feed. So we know stainless steel, because of the chip breaker, it tends to be a little bit harder on changing direction. It's a little springier material, and it creates heat. So it's recommended to use the minimum value for feed. So for instance, on a 3, on a B0 or BO3 here, you would use the 1 thou 2/10 instead of the 2 thou. On the drilling side of things, as I mentioned, as of now, this is slated to drill in steel ISO group P. That's what it's designed for at the moment on the solid drilling with the 2 geometry, the .2. And you can see the drilling parameters 4/10 to 8/10. So, or even at the largest diameter, 1 thou 2/10 to 2 thousandths. So you're really going to have, for aggressive drilling, high performance drilling parameters, you're going to be quite a bit higher on that. For a 7 millimeter tool, you're going to be in the 6-8 thousandths per rev range, I would assume, with the DDM and the DDP. So it's not a direct replacement for a drill, but it can save a tool location and get you out of a bind if you have limited tool stations and you need to do a drilling op. And as I mentioned, if you use a high performance drill, and then you can open this bore up to whatever size very quickly, you're saving the time of the tool change, and then the additional positioning time to get to the center of the part. So it can be very interesting for productivity. All right, that concludes part 2. Check back to our YouTube page for future videos of past trainings. And thanks for joining us, and have a great day.